Hello once again, Mr. Wakefield here with you, and we're getting towards the end of Chapter 4, 4.5 right now. We're going to be doing kind of the opposite of what we've been doing a lot throughout Chapter 4. Throughout a good portion of Chapter 4, we have been graphing an equation. In other words, the problem will give you an equation, and then they ask you to graph it. Well, now we're going to go the opposite way where the problem will describe a graph. As you can see here, it describes a graph by saying, the slope is -3 and the graph passes through this point. Similar type of problem here, and a lot of the problems are like that. So they describe a graph, okay? And then, so basically the problem is starting with the graph by describing it, and then you got to come up with the equation that that graph comes from. All right, so now the answer is going to be the equation instead of the question being the equation. Okay, again, going backwards. All right, so how do we find these equations that fit the description of the graph that they give us in the problem? How do we find them? There's 5 different possible scenarios that could take place here. First of all, as we've seen throughout this chapter, whenever you have a horizontal or vertical line, and you can see here that that's where it says special exceptions right here. It says if the slope is 0, and we know already that that automatically means that it's a horizontal line, okay, or if the slope is undefined, which automatically means that that is vertical. In both of those cases, no surprise, we will have a different way of doing the problem in that particular case, whereas normally, if it's not horizontal or vertical, in other words, if the slope is just a normal number, it's not 0 or undefined, then you're going to use one of these 2 formulas up here. Okay, I wrote them down over here, and then I also wrote them down over here, again, a little bit bigger so we can see it a little bit more easily. Okay, well, I'm going to talk about that right now. All right, there's 3 different scenarios in which we need to use one of these 2 formulas. Which one we use, I'll talk about how you know that, how you know which one of these 2 you use. But again, these are the ones that you use if you do not have a horizontal or vertical line. In other words, if the slope is not 0 or undefined, any other type of slope, this is you use one of these 2, and again, I'll tell you which one you use. It depends on the situation, all right? But if the slope is 0 undefined, or if they tell you that the line is horizontal or vertical, in any of those cases, we're going to do something a little bit different. It mentions it right here. It's a lot simpler, actually. I'll get to that here eventually here, after we get past these types of problems up here. All right, so let's jump right into it here. First of all, this first formula, it says that if you already know what the slope and the y-intercept are, which as you guys already know, if you have y equal mx plus b, the m is the slope and the b is the y-intercept. So you just have to plug those 2 things into those 2 spots if you already know them, and then the problem's done. And the reason why the problem's done is because unless you have a horizontal or vertical line, in which case one of the variables will be missing, other than that, though, the y and the x, you guys, are supposed to be part of the answer, okay? So you want to replace the m and the b that I boxed in right here, and I also put it in green there if you can see that on the video screen there. Those 2 numbers, m and b, are supposed to actually be replaced with constant numbers. Okay, you're supposed to figure out what those are and then put them into those spots. All right, we'll do that here in the very first problem, in fact. But y and x, you guys, is supposed to be part of the answer. Don't feel like you have to try to replace the y and x with actual numbers. That's supposed to be part of the answer. We know that these equations that we've seen in this chapter have y and x in it, unless it's one of those problems that has a variable missing, which, again, we'll see those coming up a little bit later. Otherwise, it's not a surprise that y and x should be part of the equation, and therefore it should be part of the answer, because equations are what our answers are going to be, okay? And so y and x should then be in the answer. They're part of the equation. So let's jump right into it here. It says, write a linear equation that satisfies the given characteristics. Okay, write the final answer in slope-intercept form if it's not already. Remember, slope-intercept form is y equal to mx plus b. Okay, so you want the final answer to look like this, where the m and the b actually have numbers in the place of those letters, but the y and the x are still there. Okay, question, you guys. They obviously give us the m. They tell us that. You don't even need to figure that out. But do we know what the b is equal to based on the information that they give us here? Actually, we do, because as we learned previously in the early part of this chapter, if you get a point where x is equal to 0, then that automatically means, okay, that this is the y-intercept. This point is the y-intercept. Whenever the x is 0, that automatically means it's the y-intercept. And so what is the b then? Okay, well, whenever you have x equal to 0, the y number that pairs up with it, that's always the b. Okay, so thus, b is equal to -4 automatically. Now, as a comparison, you guys, if you look at the next problem, see how x is not equal to 0 right there? If x is not equal to 0, I'll put a slash mark through the equal sign to say not equal to 0, then what? Then we what? Cannot, I'll go back to the first problem here in just a minute, we cannot assume that the number that pairs up with it there, 3, we cannot assume that b is equal to 3. We cannot. Not. Okay? And so do not say, oh, hey, b is equal to 3 because the b was equal to -4 over here. No, it doesn't work that way. The y has to pair up with x equal to 0 in order to be allowed to make that y number equal to b. Okay, it has to pair up with x equal to 0. That first number has to be 0 in order for the second number to be the b number. Okay, so if the first number is 2 or any other number besides 0, then you can't do it that way. You can't just say that b is equal to 3. All right, so b is not equal to 3 here. That's why I said you can't assume that. All right, so we'll figure out a different way to do this problem, but let's go back to the first problem and finish that up first. Okay, we now know the m. We now know the b. And so all you got to do, according to the formula up here, is to put the, in fact, I'll write it down up here and then I'll transfer it back down into the problem. You just put the -3 where the m is, then the x. Normally you'd have to, when you plug something into a letter, you got to use a parenthesis, but it's not gonna make any difference here. It'll still come out the same either way. So -3 times x because m is -3, and then you're supposed to put -4 right here. But as you guys know, when you have a term plus a negative term, plus negative is the same thing as just saying minus. You could say plus -4. It's not wrong, okay? But it's better to clean it up there and say -4 instead. It looks better that way. It looks more simplified, okay? And we know that plus negative is the same thing as minus right there. So let's bring that down here into the problem. And that's all we got to do. They told us to put it in a slope-intercept form. It is. It is in slope-intercept form here. Y equal to mx plus b form. And again, you just had to figure out what the m and the b are when you use that form, because the y and the x are supposed to be part of the answer. So that's why you know that you're done. The y and x didn't need to be changed at all. The m and the b needed to be replaced by whatever they were equal to, and we did that. And so everything is complete. Okay, now, in problem B, if the B number is not allowed to be equal to 3, what do we got to do then? We already know what the M is. They tell us that at least. But we don't know what the B is. Well, what you can do, there's more than one way to do it, but what you can do is when you know what the slope is, you guys, but you have just some random point where x is not equal to 0, okay, what you can do as a backup option, instead of doing this, is you can use this formula here. And what you do, again, the y and the x stay the way they are because they're going to be part of the answer. And then you put your slope where the m is, no surprise there. Okay, the slope in this problem is 4. Okay, let me show that to you. There it is, so we can see it. So slope is 4, I put it here. And then it says, it gives us this point here. We know it passes through that point. And it says here that the x1, y1 thing here represents any point on the line. So if they give you any point on the line, no matter what it is, as long as it passes through the line, okay, then this qualifies. And so that means what? That means that 2, 3 qualifies because it's any point, right? Okay, it just has to be any point at all, and we know that that point is passing through the line, so it qualifies. So that means that the x1 is 2. I can put it right here. All right, bring down the minus. And then the 3, since that's the y1 right here, we put it right here where the y1's supposed to go. Bring down the minus. And that is a legitimate equation. Let's go ahead and bring that down here to the bottom. Okay, y minus 3 is equal to 4 bracket x minus 2. But we're not done yet. This is a legitimate equation. Yes, we got the x and the y in there. I filled in all of the other 3 parts here besides the x and the y. So these 3 things right here that I'm boxing in, they need to be replaced with numbers, just like these 2 things up here had to be replaced, m and b. These 3 things need to be replaced, but the x and y are supposed to be part of the answer. So that's all great and everything. This is a legitimate equation for that reason. But remember, the directions say to write your final answer in slope-intercept form. So how do I take an equation that looks like this and make it to look like the y equal to mx plus b form? Okay, there's 2 steps you got to do, and then we'll be all done with this problem. First of all, when you do this form, okay, it's called the point slope form here. When you do that form right here, you clear out the parentheses first by distributing out the 4. We've seen that before from the first day of class. When you have a term times a bracket, you just distribute the term through there in order to clear out the parentheses. 4 times x and then 4 times negative 2, like this. Okay, so we get 4x minus 8. Again, this is from section back in section 6.3. A term times a bracket, you distribute the outside term to each term inside. Then, in order to get the y by itself like it's supposed to be, you take the term that is after the y. It's either going to be minus something or occasionally it will be plus. I'll show you that as well. But if it's minus, we're going to add it. If it had been plus 3, we would subtract the 3 because we want that to cancel out so that the y will be by itself. Okay? So you, again, distribute out the brackets to clear out the parentheses and then move this term over by adding or subtracting it over so that the y will be by itself. What do we get? Well, if I combine like terms on this side now, don't I get 4x minus 5? Because negative 8 plus 3 is negative 5. Like that. And we did it. Okay, so we got our equation. We then transformed that equation into slope-intercept form like they asked us to do. Okay, and we now not only have our equation, but it's in the correct form as well, the slope-intercept form that they asked for. Okay, let's keep going here. Once again, they give us the slope. Once again, they give us a random point. But once again, it is also true that x is not equal to 0. So what does that mean? That means that we cannot say that the b number is negative 3. The negative 3 would have to pair up with the first number being equal to 0 here. But the first number is not 0. So we can't say what? We can't say that b is equal to negative 3. Not allowed to say that. Cannot. Okay, so what do we do instead? Whenever we have the slope, you guys, and we have some random point which is not the y-intercept because, and I know it's not the y-intercept because x is not 0. In that case, we use this secondary formula, the point slope form. All right. Again, let's come back up here again. I'll erase the old problem so that we can see how that all comes in. So the x and the y are already supposed to be part of the answer. The brackets are supposed to be there too. But then these three things, the y1, the m, and the x1, they've all got to be replaced by of the appropriate numbers. In this problem, it says that the m is 1/8. So let me put the 1/8 right here. Okay, and then it says that the point that they gave you is -2, -3. Okay, let's talk about that. We've seen something like this before earlier in this chapter where, in fact, let me write it down up here. Get rid of the previous problem there. So this point right now is -2, -3. So that's the point that they give you. Therefore, it works because it says any point will work as long as it's on the line. Okay. So what you do is you plug in -3 right here. But what did we talk about when we had that slope formula back in 4.3? The one where you plugged in the numbers, but the numbers sometimes made it plus. See how we had 3 plus 1 right here, even though the formula had only minuses in it? How did that become a plus right there, even though it's supposed to be minus in the denominator right there? It's because the number that you plugged in behind the minus sign was -1. You're supposed to do, or sorry, I was looking at the wrong one there. It's this one right here. You're supposed to do 3 minus -1, the second x value minus the first x value. That's what it tells us to do here. So 3 minus -1. There's that double negative again. Remember, whenever you plug in a negative number behind the minus sign right there, it becomes plus, and that's why that's plus there. What's going on currently in the current problem is exactly the same. Okay, because the let's go back up here. Because the y1 number is negative, and you already have a minus built into the formula in front of that, that's going to make that a double negative. It's going to make it +3. So if the y1 is negative and you plug it in, it becomes minus negative, which transforms into plus. Okay, why was the last problem minus right here, but this current problem is going to be plus? It's because the number that I plugged in behind the minus was positive. So the minus stays minus. If it's -3, then there's no double negative there, right? Okay, so it's just -3. But because I plugged in a negative behind this minus right here, that makes the double negative, and that's why it becomes plus. Same thing happens over here. We already have a minus sign built into the formula in front of the x1. So since the x1 is negative also, -2, that means you have minus -2. Again, that's a double negative. And what I mean by double negative here is, again, when you have a term minus a negative term. All right. The first term, here it's positive x, but it doesn't matter what the sign of the first term is, okay? It's just if you have a term minus a negative term, then that second term there becomes a plus in front of it. Minus -2 becomes +2, okay, because of the double negative. So let's bring that down. Y plus 3, 1/8, x plus 2, with the equal sign, don't forget that as well. And so once again, we have a legitimate equation. Our x and y is in there, but the other spots were filled in. You don't have any other variables besides x and y like it's supposed to be. The other letters have been replaced by numbers. But it's supposed to look like the slope-intercept form, right? How do we learn how to transform it from the point-slope form, all right, that we were just looking at right here? How do we transform it from that so that it looks like this? All right. The two steps that we did were what? We distribute and to clear out the parentheses, and then we move over the 3 right here, right? Just like we moved over the -3 right there. So let's distribute the 1/8. Okay, 1/8 times x. Since 1/8 is a constant fraction, there's no variable in it. Whenever you multiply any constant, even if it's a fraction, okay, anytime you multiply a constant number times just x, not 3x or 4x, but just x, then it just is, the two things just come together. Okay, there's nothing to combine there. Just like 3 times x would be 3x, 5 times x would be 5x, in the same way, 1/8 times x is just 1/8 x. The other part here, we got to work on it a little bit more. 1/8 times 2. As you guys know now, when you have a fraction times a regular number, make the regular number into a fraction also. And then you can cross cancel. Since these are all single terms, there's no limitation on the canceling at all, so you can cross cancel. You don't have to factor first or anything like that. Now notice that this is positive, and as you guys know, when you distribute, you got to put pluses or minuses in between your answers. So I put that minus in between the 4x and the 8 because it was -8. In the same way, since this is positive 1/4, I've got to remember to put that plus in front of it since the 1/4 is positive. Okay. So it's always tougher when we're working with fractions here, but we just got to be careful. All right. Last step here is that we need to move over the 3, just like we moved over the -3 in the last problem, so that y would be by itself. Since the 3 is positive, I've got to subtract the 3. And this brings into play when we learn how to add and subtract fractions. How do you do 1/4 minus 3? Well, again, if you are taking a fraction 1/4 and you are adding or subtracting it with a regular number like 3, you need to make the 3 into a fraction. And then since we're subtracting, we need an LCD here. Remember, you got to make the denominators the same when you're subtracting. The LCD would be 4, wouldn't it? Because anytime that you have two denominators and one of them is equal to 1, the other denominator is automatically your LCD. So what do I get here? That would be 12/4 if I make the denominator the same. This one stays the same because the 4 is already in the denominator. So the important thing is that we made the denominator the same. And then 1 minus 12 is -11/4, isn't it? You can either put the negative in with the 11 or you can put it in front, but remember it's negative. And when you combine like terms, you guys, remember that you got to have pluses or minuses in between your answers, right? Now the 1/8 x doesn't combine with anything, but because these two numbers combine together to be a negative answer, -11/4, we got to say -11/4. If it had been positive 11/4, then you'd say plus. Just like you always would when you combine like terms. I know it's a little bit trickier now because of the fractions, so just want to make sure you remember those rules. All right, when you're combining like terms, you got to put pluses or minuses in between the answers that you get when you combine like terms. All right, and that's what we're doing here with these three terms on the right-hand side of the equal sign. All right, we end up with two answers. The 1/8 x didn't combine with anything. These two combined, but you got to put a plus or minus in between. All right. In this case, it's minus because the answer was -11/4 when we combined it. Okay. Okay, moving on here to the next problem. You can see here that for the first time, they do not tell us what the slope is. In the last three problems, they told us what m was right at the beginning of the problem, correct? And so they don't do that this time. That's a problem here because unless they tell you in advance that the problem is horizontal or vertical, in which case you're not going to need to do these formulas up here. You can do the simpler ones, which I'll get to in a minute. You can see here on the second page of the 4.5 worksheet, it tells you in advance that it's vertical or horizontal. In that case, you don't need to figure out the m, and I'll show you how to do those problems here in just a few minutes. But otherwise, you need to figure it out if they don't tell you what it is already in advance, like they did in the first three problems. So the question is how do I figure it out? Because you ain't getting anywhere unless you figure it out. Okay, you need to know what the m is in order to use the formulas here. All right, and so the way you do it is that since they gave me 2 points, I use this formula that I was just mentioning a few minutes ago from back in 4.3. Okay, I use that formula to figure out what the slope is. Because anytime that they give you 2 points, okay, first point, second point, for example here, you can then plug those two things into here just like we did in 4.3, and it'll figure out the slope for you. Okay, so let's do that same exact thing here. I'll go ahead and write down the formula off to the side so that we just have it in front of us here. Y2 minus Y1 over X2 minus X1. And then, so that means that we need to do the second Y minus the first Y. Let's write that down over here. So we got what? We've got the -1 minus -11. Now remember, if you plug in a negative behind that minus, it becomes what? It becomes plus, doesn't it? Okay. And then same thing on the bottom, only now you do the x's. The second x minus the first x. 3 minus -3. Again, you plugged in a minus behind the, you plugged in a negative behind the minus sign that's already in the formula down here in the denominator. So 3 minus -3 is the same thing as 3 plus 3. And again, when you're figuring out the slope here with the two numbers being added or subtracted together on the top and bottom, just like we did in 4.3, figure out what those numbers are equal to first, and then put it in lowest terms. So 10/6, if I put that in lowest terms, that's going to be 5 and 3. And so the slope is 5/3. 5/3. Okay, now, we now know what the slope is, just like we did in the first three problems. Okay, here's the thing. As always, if you already know what the slope is, you look at the points they gave you. All right. In the previous two problems, actually the previous three problems rather, they gave us 1 point, right? And if that 1 point had x equal to 0, then we knew what b was. If that point did not have x equal to 0, then we had to do the secondary formula. It's the same thing now in this problem. It's just that now we have 2 points to look at. Do either one of these 2 points have x equal to 0? No, they don't. If one of them did, then you just have to take the number that pairs up with x equal to 0, just like we did here, and then you would know what your b is. Okay? But since neither one of these have x equal to 0, you're going to have to do the same thing we did in the last two problems, b and c right here, where you have to use the point slope formula with the bracket and all that. Okay? So then that then begs the question now, which one of these 2 points do I use? Because the formula up here says you can use any point on the line. Okay, it doesn't say anything about 2 points though, right? Okay, well, remember the key word there is any. And so because you're allowed to use any point on the line to plug into the y1 and the x1, you can choose which one of those 2 points you want to use. Okay, it's your choice since they said any. All right, so let's go ahead and take a look at it here. I'm going to go ahead and pick the second point here. You could pick the first one. In fact, if you pick the first one and you finish off the problem and you put it in the slope-intercept form and all that, okay, I promise you your answer will be exactly the same as mine if I do this point. It does not matter. It will look different at first if you do this point and I do this point. Okay, it will look different at first, but at the end it'll look the same, and that's what's important. Okay, so I'm going to do this point. All right, but again, either one is fine. Okay, so that point is 3, -1. That means that the 3 has to get plugged in right here. I need to change the slope. I forgot to fix that. What is the slope in this current problem? It is 5/3, right? We just figured that out a moment ago. So 5/3 will go right there. We put the 3 right here. Does the minus become a plus though? No, it does not, because it's not a double negative. It's just +3 being plugged in behind that minus, so it's not a double negative situation. Okay, now what about the -1? Since the -1 is negative and you're plugging it in behind the minus here, that's a double negative. Y minus -1. That becomes y plus 1. And there's your equation, at least initially here. We still got to put it in the slope-intercept form, the y equal to mx plus b form. But let's bring this down here first. Y plus 1 is equal to 5/3 bracket x minus 3. So then what are the 2 steps I got to do in order to get it into the slope-intercept form? I've got to distribute out the 5/3 through the bracket here. 5/3 times x, just like 1/8 times x in the last problem. 5/3 times x is 5/3 x. But what about 5/3 times negative 3. Not 3, but negative 3. Well, remember, you guys, and we didn't really see this when we were doing fraction multiplying in Chapter 8, okay? But when you have any negative signs involved, and I'm not talking about when you got like more than one term in your numerators and denominators, because the minus signs, it just depends on the situation. But if you have like a single term with a minus in front of it, or if there's a minus outside of one of the fractions in front of it, okay, that creates a different situation here. When that happens, and we see that in this section a lot, where you got just single terms in all four places right here, the two numerators and the two denominators. So if there's any negative signs at all in that situation, you got to be careful with your signs. Remember, this is a positive fraction times a negative fraction. Positive fraction times negative fraction. So if it's a single term in all four places here, all right, if there's any negatives at all, you got to consider the sign of the answer. Okay? Make sure it comes out correct. All right, and it may automatically come out correct anyway, but you got to double check it. 3 and negative 3 cross cancel and become negative 1 over 1, though, don't they? And then after I now multiply, I get negative 5 over 1, which is negative 5. Is that the correct sign, though? The way you check that in this situation is you check, and again, this is just when you got single terms in all four of these places here. I'm not talking about the bigger problems in Chapter 8. But in that case, look at the sign of each fraction. This is a positive fraction, 5/3. This is a negative fraction, negative 3 over 1. Positive times negative is negative. Okay, sometimes it'll be the wrong sign here. You need to adjust it. So that's why I'm telling you to double check. Positive times negative is negative, so that is the correct sign. We don't need to change the sign. It's correct. Minus 5. If it had been positive, you'd have to say plus 5 because we're distributing here. Okay, you got to have a plus or minus in between the answers. Then we move over the 1, just like we moved over the 3 and the negative 3 in the last two problems. Since it's positive 1, we subtract it over. Okay. 5/3 x doesn't combine with anything there, but negative 5 minus 1 is negative 6. And we did it. We got it in the slope-intercept form. So let's review here. If you know the slope and you know the y-intercept, which I know this is the y-intercept because x is equal to 0, you just take the number that pairs up with x equal to 0, you make that your b, you pair it up with the m, you plug it into the slope-intercept form, and the problem's done. Nice short problem right there. But if you know the slope and a point that's not the y-intercept, because x is not equal to 0, then you use the secondary formula here, the point-slope form that we looked at the top of the page here with the bracket. Okay, and we did that in both of these two problems here. Make sure that the problem ends up in slope-intercept form here at the end. But if you have just 2 points, okay, 2 points, no slope or anything, just the 2 points, then you have to use those 2 points to find the slope. And then once you find the slope, you then do the same thing we did in the other problems, where if any of your 2 points has x equal to 0, then you can figure out what b is by figuring out what pairs up with x equal to 0, just like we did here. However, these 2 points right here were not x equal to 0 on either one of them. They were negative 3 and 3. And so we had to, again, use the second formula because we did not know what the b was. Okay, so that's what you do when you just have 2 points and no slope. Okay, so that brings us, as I promised, to, as we move to the second page here, what happens if the problem just says it's a vertical line or it's a horizontal line? What if it says that and then it gives you a point? Okay, let's talk about that. It's a much shorter problem here, as you're going to see. A vertical line, as we learned back in section 4.1 and 4.2, a vertical line means what? It means that the x's are always the same and the y is missing. Okay? The y is missing and the x's are always the same. That's going to be important here for the equation. X's are always the same. Okay, if the x's are always the same and the y is missing, and since this point right here has x equal to 1/2 in it, right? Wouldn't it make sense that that would be your equation? Just that thing that I just wrote down right there, x equal to 1/2. The reason why that makes sense is because the y is missing, so you can't have a y in here, right? Okay, so we should only have x in there. And then the x's are always the same. Okay, so x can't be equal to anything else besides 1/2 if it's always equal to 1/2. All right. Remember that when we did those graphs before, the x's were always the same. And if you look closely at the graph here, every single point on this graph has x equal to 2. And so if every single point has x equal to 2, look at what the equation was that paired up with it, with the graph. X equal to 2. All right. So whatever that number is that's always the same, just say that the variable is equal to that. Leave the other variable out. In this case, leave the y out. Just say that the x is equal to that number that's always the same, and then that's your equation. That's all you got to do. Okay? So, if the y is missing, you just have to take you just need to first of all realize that the x's are always the same, but then because that's true, just look at the one point they gave you, figure out what the x is, it's 1/2, and then that becomes your equation, x equal to 1/2, because the y is missing, so you should only have x in there. In the same way, when you have a horizontal line, that means what? That means that the x is missing this time, and the y's are the ones that are always the same. The y's are always the same. And since the y's are the same, you do the same idea as we did over here, only now you take the y. Since y is equal to -4 in this one point that they gave us, and it's saying that that point is on the line because it says that the line contains that point. That means that it's on the line, right? And so because y is equal to -4 on this point right here, and since the y's are always the same, you just simply say y equal to -4. Again, it makes sense because the x is not supposed to be there. And since the y's are always the same, we just say y equal to -4. So to review here, if the x's are always the same, okay, just take the point that they gave you and say that x is equal to that. That's all you got to do. In the same way, if the y's are always the same, which is the case with the horizontal line, okay, and again, I mentioned that also back in 4.1 and 4.2. If you've got a horizontal line, the y's are always going to be the same and the x is missing. That's why I knew that, okay. Pardon me if I didn't mention that before a few minutes ago, but now you can see why I reasoned that out. Okay, a horizontal line means that y is always the same and x is missing. Okay, so that's why I wrote that here. But that means also to realize that when the y's are always the same, all right, you just take the one y value that they gave you with the one point that they gave you. Just say that y is equal to that and you're done. That's it. Y equal to -4. And again, there shouldn't be an x in there, so the equation really is this simple. All right? Because there's not a second variable. All right? So let's take a look down here. There's 4 problems. Okay? Again, you see here it says vertical line. All right? So that's going to be similar to this one here. But these other 3 problems, you can see, first of all, in 1 and 2, the slope is not 0 and it's not undefined, so it's not going to be one of those horizontal or vertical line special situations like we saw up here. So you're going to have to use either the first formula or the second formula at the top of the first page. These formulas here, one of these 2, okay, for this problem and for this problem. All right, it all depends on what they give you here, and we'll talk about that when I show you the answers. And then here, you got to figure out what the slope is equal to first. And if the slope is not equal to 0 and it's not undefined, then again, that means that it's not going to be the special horizontal or vertical situation. And so again, you'd have to use one of these 2 formulas. Okay, so always use one of these 2 formulas unless it's a horizontal or vertical line, in which case you just do what I just showed you here. So try those 4 problems. Okay, hit the play button. We'll see how they come out. Okay, number 1, we know the slope. But because the point that they gave us has x equal to 0, that automatically means that the y value that pairs up with the x equal to 0 is the b number. All because the x part was 0. All right, just like we saw in the very first problem on the first page, problem A. Okay, and so that means that I can plug in the -3 into the mx plus b formula. Okay, plug it into here. Plug the -3 into there. Plug the 5 into the b part. Since it's not negative, the plus stays the same. Okay, it's just plus 5. And there's your final answer right there. It's supposed to be in slope-intercept form. It already is, so you don't need to do any additional steps. Number 2. They tell us a slope. But this time, the point that they gave us to go with the slope, the x is not equal to 0, it's equal to 2. And so you're not allowed to say that the y part is b. Okay? Here you're allowed to because it paired up with x equal to 0. Here you're not allowed to say that this is equal to b right here because it doesn't pair up with x equal to 0. So we use that second formula instead, like we've been doing in that situation. All right. We plug in -3 into the, and again, let me write down the formula here, just so that we don't have to keep on flipping the page over here. Here's the formula. So I put the -1/2 into the m right there. That's why you see that there. And then you put the -3 here, but it's the double negative again. That's why I ended up with y plus 3. Okay, that's why you see y plus 3 up here. And then since 2 is positive, right here, 2 is positive, then it's just x minus 2. Okay, it's not a double negative, so the minus stays the same. And that's why you see x minus 2 right there. Now, we still got to put it in the slope-intercept form. Okay, and so I need to distribute that out. Okay, -1/2 times x is -1/2 x. All right, but then negative times negative is positive. Again, be careful with these negative signs when you're multiplying two simple fractions that just have single terms in the top and bottom. Okay, but because it's negative times negative, that tells you no matter how this comes out, you guys. I know this is going to look like 1 times -1 is -1, but that negative on the outside kind of changes things up a little bit. That matters also. So that's why it's important to look at that and say, this is a negative fraction, this is a negative fraction, -2/1 coming from here. Negative times negative is positive, so you don't want to say the answer is -1, you want to say that it is +1. Negative times negative is positive. So make sure that when you distribute, especially on that second part right there, make sure you get the sign correct. Negative times negative is definitely positive. And then you could do your cross-canceling also. And that's where the 1 comes from. Then we have to move over the 3, right? Since it's +3, we subtract it over, and there's your final answer right there. 1 minus 3 is -2. Problem number 3. Oh, it's a vertical line. That means that the y is missing, and all the x's are the same. So you take the one point that they gave you, the x is equal to 3 in that particular point, and so that must mean that all the x's are equal to 3, okay, because of the fact that one of the x's is equal to 3 and all the x's are the same, so the x can't be equal to anything else, right? So since you know that that x is equal to 3, then the entire, just like I did in the problems right above here at the top of the page, okay, when I said x equal to 1/2, the fact that all the x's are equal to 3 means that your equation is x equal to 3. Just like all the x's up here were at x equal to 1/2 because one of them was equal to 1/2 and they're all supposed to be the same. And so moving on here into number 4, when they just give you 2 points, you got to figure out the slope first. Okay, so -3 minus -1, same thing as +1. The second x minus the first x, 2 minus negative 4, okay, is equal to 6. All right, because it's 2 plus 4. Double negative again. Putting that in lowest terms, we get negative 1/3. Yes, you could put the negative, you could keep the negative inside of the numerator like it was here. I just like to move it out into the front. And as we've already talked about, that's the same thing. Okay, if you've got a negative on the top only, when you've got just two simple numbers right here on the top and bottom, you can move it to the front. It still means the same thing. The important thing is that it's still negative, all right? And it is, no matter whether you put that negative on top or on the front. Then, as I did in that last problem on the front side of the worksheet, they gave us 2 points, right? They gave us 2 points. Neither one of them have x equal to 0, so I can't just figure out what the b is, okay? Because none of these have x equal to 0. So I have a choice then. I could either make this my x1, y1 that I plug in, or I can make this one my x1, y1. Either way is fine, all right? Because it could be any point, like we said in problem D on the front, okay? I picked this one, but I promise you if you pick this one, even though the answer will look different at first, when you get down to the very bottom, it will be this answer, no doubt about it. You'll get the same answer I do in the end. Okay, but I'm going to go ahead and do this point here just to pick one here. All right, I plug that in and I get this right here. Again, double negative on both this part and this part. That's why you have +1 and +4. Okay, you're plugging in these negative numbers behind where there would normally be minus signs already there. I then distribute this out. Okay, negative 1/3 times 4 is negative 4/3. Again, you have a negative fraction times a positive fraction. So that's a negative answer, thus the minus right there. Okay. Then I need to move over the 1. This is where we need to be especially careful here. How did I get negative 7/3 right here when I move over the 1? Well, negative 4/3, as I mentioned back in 8.4 when we learned how to add and subtract fractions, if you are adding or subtracting fractions here and the first fraction has a minus in front of it, you must put that into the numerator. Otherwise, it will get forgotten about and it'll be as if the negative wasn't even there, and that can't be right. Okay, the negative is there for a reason. It counts. So we need to move that negative into the numerator. I did that in 8.4 right here in this problem, very first problem in 8.4. So in the same way, because I have a negative in front of the first fraction here as I'm subtracting here, I'm going to move that negative into the 4 right there, into the numerator, like I said. And now my common denominator is 3, because I have 3 and 1 as my denominators. I multiply this one by 3, and now I have the same denominator, so I do negative 4 minus 3. Negative 4 minus 3 is equal to negative 7. Sorry about that, there it is, negative 7. And so your fraction there will be negative 7/3. Okay? Now it's negative. All right? So remember what we said. When you're combining like terms, you got to have a plus or minus in between your answers. Since this is negative, you want to put a minus, okay, in front of that term. So yeah, since this is a negative fraction, you put the minus in front, but you don't keep the minus inside the fraction here. Let me explain what I mean by that. Back in the second day of class, when we had these division problems and we figured out that one of the fractions was supposed to be negative, what did we do? In other words, right here we have negative divided by positive. So that was supposed to be a negative answer right there. What did we do? We put the minus in front, but we didn't keep it on the inside. There's no negative inside the fraction, it's just in the front. It's the same idea here. If you combine these two things and you get a negative fraction, okay, you just put the minus in front, but you don't keep it on the inside. Same exact thing. If this had been positive 7/3, you would just say plus 7/3. Again, just like in 6.4, when you get a positive divided by a positive, that's a positive answer, right? So what do you do when it's a positive answer? You put the plus in front of the fraction, but no negative signs or anything on the inside. No negative signs on the inside of the fractions either way. You either put the plus in front if it's positive or the minus in front if it's negative. but nothing on the inside as far as the minus signs go. Okay. Again, if this had been positive, you would say plus 7/3, but because it's negative, you say minus 7/3. I just want to make sure that we don't mess up the signs there. Okay. We don't deal with fractions and combining like terms very often, so I just wanted to be extra careful that you understood that. Okay, so that concludes section 4.5. We're going to move on to a whole different thing, although there will be a little bit of graphing involved in the next section, but it's a whole different thing mostly. So yeah, let me know if you have any questions about graphing lines and everything related to that as we conclude 4.5 here. Otherwise, you have a great day and take care, and we'll see you back for the video for section 4.6.